Hi guys, welcome to Soil Science Laboratory, Soil Chemistry part. My name is Nanchaphorn. I'm a scientist as your host today. Today I'm going to present you the first laboratory of Soil Chemistry part. For the first lab, we will start with the basic soil analysis, that is soil pH, lime requirement and electrical conductivity. So let's start. The most important chemical properties of soil as a medium for plant growth is the pH value. Most of micronutrients can solute in the soil solution at neutral pH, but if soil is acidic, some micronutrients will be solute more in soil solution and toxic to plant. If the soil is more alkaline, some micronutrients will be precipitate and are not available. There are many methods to estimate the pH value, for example, using the colorimetric or pH meter. So today we will determine pH value of our soil samples using pH meter by AOAC method. For using pH meter, we determine the activity of hydrogen ions in the soil solution. The voltage obtained from an electrode will be calculated and shown as a pH unit. We will determine pH with 1:1 ratio of soil to water. You can download the full method from the link that I give here. We will start by weight 10 grams of the soil that ground and pass through 2 mm sieve into the beaker. Add 10 mm of distilled water to the soil sample. Mix thoroughly 5 seconds with glass rod and let soil water suspension stand for 30 minutes. Here is the soil sample after 30 minutes. Before we measure the pH of the soil sample, we have to calibrate the pH meter. Calibrate pH meter to appropriate setting using two standard buffers. In Thailand, most of soil are acidic, so we will use standard buffer pH 7 and 4. Here is the electrode of pH meter. We will adjust the electrode using buffer pH 7. The calibration method of the pH meter just follow the manufacturer's instructions. And then insert the second buffer, pH 4. And then we will determine the pH of soil sample. Before analysis, stir the test sample with glass rod. And then insert electrodes of calibrated pH meter into the beaker. And then record the result. So the pH of our soil sample is around 5.74. It is slightly acidic. After finish determine the pH, clean and rinse with DI water. And keep the electrode in potassium chloride solution. After we determine the pH of soil sample, if the soil sample is neutral, which is around 6.5 to 7.5, it is okay. Micronutrients can be solute into the soil sample. But if the soil pH is more than 7.5, it is slightly alkaline or strong alkaline. So we need to decrease the pH down by adding some sulfur or organic fertilizer. And if the pH decrease more than 6.5, it is slightly acid or strong acid. What should we do? We have to neutralize the acid soil by adding some lime. The lime in agricultural is mainly carbonate, oxide, and hydroxide of calcium and magnesium. So the lime in agriculture, for example, is the limestone or calcium carbonate, the quicklime or calcium oxide, and the dolomite or calcium magnesium carbonate. The next step is how we know the amount of basic that we need to add. So the next experiment we will estimate the lime requirement. The method we use to find the amount of lime is called Woodruff buffer. This buffer pH is 7, which is neutral. So we will add this buffer into the acid soil and determine the pH after adding this pH. We will add this buffer into acid soil and determine the pH. The decreasing the pH can interpret the amount of hydrogen ion in soil solution. After that, we will make the standard set of hydrogen ion versus pH. We will start with the standard set of hydrogen ion. Place 10 ml of Woodruff buffer in a clean 50 ml beaker. And then add precisely of standard 0.1 molar hydrogen chloride in each beaker for 0.1 2, 3, 4, and 5 ml. And then add distilled water to make the volume up to 15 ml by add the first beaker for 5 ml, then 4, 3, 2, 1, and the last one is 0. Weigh 5 grams of soy sample in a clean 50 ml of beaker, and then add 10 ml of wood ups buffer solution into the beaker. Stir with a glass rod and wait for 30 minutes before determining the pH value in the soy suspension. After 30 minutes, determine the pH value in the standard set and the soy sample. Record the pH value. And then plot the millimole of hydrogen ion versus pH value. After adding the wood rub buffer into the soil sample, we can determine the pH 5.94. Now we go into the third part of this laboratory, which is the electrical conductivity. We determine the soluble salts to know the salinity of the soil sample. The usual method to quantify the soluble salts concentration in soil is to measure the electrical conductivity in soil solution or soil water extraction. The electrical conductivity refers to the ability of a material or solution to conduct an electrical current. For today, we will determine the electrical conductivity with a conductivity meter in a saturated phase of soil and water. Weigh approximately 400 grams of air dry soil into the plastic bottle. Add deionized water into the soil and stir with the spatula. Add some deionized water and stir until the soil is saturated with water. This is nearly saturation. The paste slide freely. We need to add some deionized water. At the saturation, the soil paste crystals as it reflects light and flows slightly. And the paste slides freely and cleanly off the spatula for all soil. Now the soil is saturated with water. Apply a Buchner funnel with the vacuum flask and then add the filter paper in the Buchner funnel. Then transfer the saturated paste into a Buchner funnel and collect the saturated paste extract in the vacuum flask. Collect the soil extract into the tube. Next, we will determine the electrical conductivity using conductivity meter. Before that, we have to standardize the conductivity meter using the standard potassium chloride solution following manufacturer's instructions. Here is the standard potassium chloride solution. After calibrate the conductivity meter, clean the meter with deionized water. And we will read the soil sample extract by immerse the conductivity meter into the soil extract. And then read the electrical conductivity and record. We will report the electrical conductivity in a decisiemens per meter. Here is the result of this laboratory. For the first part, the soil pH is 5.79. So you have to discuss whether the soil sample is neutral or alkaline or acidic, and then give your recommendation if you need to improve the soil. And for the second part, the lab requirement, I have shared the Microsoft Teams. All the result is in the Microsoft Teams. Each student have to set the graph of the standard hydrogen ion versus pH, and then determine the millimole of hydrogen ion in soil sample. Then calculate the LAM needed to neutralize the hydrogen ion in the soil sample and report the amount of LAM per right. And the last part, the electrical conductivity of the soil sample, you have to report the EC in decisiemens per meter. And then everyone have to send your report in the Microsoft Teams in the link that I leave below this clip. And if you have any question, feel free to contact me in by email, and I will leave my email below this clip too. Okay, it's done for today. See you next clip. Bye bye.